Mark Glick from the Hawaii State Energy Office yesterday said that Hawaii is, in order to create electricity, is one of the dirtiest states in creating electricity by using crude oil and aging generators. So today we're here to talk about how to solve some of this problem. And one way is now battery storage that is happening in all the utility scale solar projects. So my panel today, I'd like to welcome Bernie Cotlier, who is speaking on energy storage and microgrid training and certification, or ESAMTAC for short. And I also have Ryan Park here of Business Development for Moss Construction. So welcome and thank you for willing to participate on this panel. Bernie, let's start with you. In Hawaii, requirements for installing PV installations requires that the electricians be licensed in the state of Hawaii. And that's for safety reasons, protecting not only them, but the public as well. With utility scale solar farms, we are now having battery storage included in the design. So should these installations require certification in order to install them? And we are the only one, and we're only talking about commercial and utility scale solar projects. But before you answer that, could you give a little brief description of your background?
Sure. Thank you, Damien. As you said, my name is Bernie Cotlier, and I'm the Executive Director of the California Labor Management Cooperation Committee, or the LMCC as we call it. And it does just what it says. It fosters cooperation between management, the contractors, the owners of the companies, and labor, the electricians who work for them. So we work for the benefit of the whole industry. I started doing this about 18 years ago in Los Angeles, and after a few years, I was asked to do it statewide in California. And that has meant doing a lot of things for the benefit of the industry. It includes things like developing training and education for the electricians and the contractors. Also, I've been on a number of advisory committees with the Public Utilities Commission, California Energy Commission, the California Air Resources Board. So I've been involved with energy, training, and education for quite some time.
Thanks, Bernie. So could you continue with your presentation and show us the kind of the reasons of why energy storage, the battery installations, whether certifications are needed or not needed in this situation?
Okay, yes, thanks, Damien. Well, first of all, a little bit about energy storage before we get into that training and question. I'm sure many of you are familiar with energy storage, but it's, I think, good to have some background. Energy storage is a rapidly expanding industry. And, this graph is just sort of a simple representation, but the actual numbers also reflect very, very strong increase in the amount of energy storage installations. Oop, that one jumped ahead. And you can see here, these are actual numbers of cumulative energy storage installations in the United States through 2024, through last year. Now, I know some of you may be thinking, well, that was true through last year, but we have a new administration in DC, so, probably not going to be true this year. But actually, that's not the case. Despite the fact that we have a change in administration and some uncertainty in policy, there is a huge increase for 2025. And the reason we know that, even though that we haven't finished the year, is because of all the contracts that have already been signed. Many of these projects are planned 2, 3, or even 5 years in advance. So 2025 is going to be another record year for installations of energy storage in the whole United States. And some people will probably ask, well, how about the different regions? How does it vary? Well, you can see from this map, you can see from this map here that there are significant increases in energy storage all across the country, but the region that has the largest increase is the Southwest and Hawaii. You see Hawaii is mentioned there in that gray area. Significant, I think that's over 12%, 12 gigawatt, or I can't even read this slide, 34% increase in energy storage, including the state of Hawaii. So tremendous increase in this region especially. So what are the reasons this has happened? Why are we seeing such a big increase in energy storage deployment? And of course that includes microgrids as well. One of the reasons is something that's, I think, unexpected in this time of inflation. We know, particularly since the pandemic, we've seen major inflation in so many areas and so many sectors. But in energy storage, we're seeing exactly the opposite. In the last 3 decades, energy storage costs have declined 98%. They are only 2 cents on a dollar compared to 30 years ago. That's an amazing decline in the face of all this inflation that we're seeing. Does anybody know what other energy sector has had such a big price decline? Anybody? Damon, you know what other area has had a huge price decline?
I didn't see any price decline.
Yeah, well, it's solar, and that probably won't surprise some of you who know something about the industry. Solar has declined. The cost of solar panels, you may remember that back in the 70s and 80s, the only one who could afford a solar panel was the U.S. government, and NASA was putting them on satellites. And then the prices literally came down, sort of fell down, back down to earth, and they've been declining ever since. And that's the reason we see so many solar panels in so many places. But even with that big decrease in cost in solar panels, the cost of energy storage, the decline in the cost of energy storage has actually been faster and more significant than the decline in the cost of PV panels. So that's one of the big reasons, cost. We heard a lot about that in the last panel, how things have to pencil out. So energy storage is really penciling out with these lower costs. Another reason that energy storage is growing rapidly could be best demonstrated here in the state of Hawaii. And some of you may be familiar with this installation. Damien, I think you are. This big installation at Kapolei has replaced the last coal plant on the islands in the state of Hawaii. And as I think we all know, coal plants not only burn fossil fuel, but they also put a tremendous amount of pollutants in the air, including mercury, which is very toxic. So we've had a huge environmental advance by building this fantastic installation of energy storage in Kapolei, and it has replaced the whole capacity of that coal plant. And this is really important for all of us who are concerned about sustainable energy, because when solar and wind first started becoming popular, the fossil fuel people said, well, it's not going to work because you only generate energy when the sun is shining or the wind is blowing, and you need base load. And without base load, these things are not reliable. Well, energy storage has been proven to be a replacement for these fossil fuel plants in turn of providing base load power. And this is a great example where this huge coal plant has been replaced by a major energy storage installation. And congratulations to Hawaii for that. So this expresses another reason why. It's not just that energy storage costs have declined, it's also because energy storage is the key baseload solution for sustainable energy generated particularly by solar and wind. But unfortunately, there is a fly in the green energy ointment. All of this sounds so great and wonderful, but there are challenges. And one of the big challenges we have with energy storage is safety. And that literally is the fly in the ointment. And we don't have time today to give you examples of all the things that have happened that have caused people to be more concerned about the safety of energy storage, particularly battery energy storage, but I'm just going to mention a few. Last year in September in San Diego, there was a major energy storage fire and explosion. It got a lot of press and not good publicity as well. You may have heard, for those of you who pay attention to these kinds of things, about a major fire and explosion that had happened in Arizona. Oops, it's going ahead. In Arizona in 2019. This one made national headlines and also caused the industry to become very cautious and a lot of public sentiment and concern about the safety of energy storage. And the biggest one we've had recently was in Moss Landing. This was the world's largest energy storage facility. The largest in the world, literally went up in flames in Moss Landing recently. And as you can imagine, this also has caused a lot of concern about the safety of these energy storage facilities. So some of you may be thinking, well, what about Hawaii? Have we had any of these problems here? And yes, unfortunately, we have this energy storage facility at the wind farm at Kahuku. In 2012, there was a fire that destroyed this facility as well. So it has been an issue in Hawaii as well as in Arizona and California and other places. So with these examples, and unfortunately there have been more around the world and in the States, we've come to the understanding that energy storage, as great as it is, has to be done right because there are critical safety issues. So what are some of those critical safety issues? How many in the audience are familiar with the term thermal runaway? I see a show of hands, thermal runaway. Yeah, not too many. But it is one of the reasons that energy storage, particularly battery energy storage, is a great concern because thermal runaway is a process where you have a conflagration that starts and literally runs through the whole energy storage facility. And we have not only fires in these situations, but explosions. And those explosions can cause projectiles to fly. They emit toxic fumes, gases, and chemicals. They're very, very dangerous. And the temperatures that are generated in these thermal runaways can be over 1,600 degrees Fahrenheit. And I'm sure none of us would like to be anywhere near 1,600 degrees Fahrenheit. Oops, these slides have a mind of their own. In any case, so these are not just fires. They're more serious and hazardous events that cause people to be concerned. So that's one side of the safety concern. The other side, another side of the safety concern with energy storage, with battery energy storage, is the amount of power that's in these facilities. What you're looking at here is a 40-foot container. And they also, generally, these kinds of commercial or industrial or utility scale energy storage facilities are either in 20-foot or 40-foot containers. And they're generally either a megawatt or 2 megawatts of power. That's a tremendous amount of power in a very small space. So the danger here is particularly to workers who are on the job, who are installing this, building out these facilities, and after they're deployed, maintaining them, going inside a container of batteries that can be 1 to 2 megawatts of power. It's sobering. And what happens is when people go in there, how safe they are depends on how well trained they are and how much they understand about the dangers. You know, I've showed slides like this in a number of presentations over the years, and people have come to call these the beekeeper suits. And I say, well, why are they wearing this big suit, you know, to work on this? Well, these are actually in the trade called 40 cal suits. And they are designed to protect the workers who are installing, commissioning, maintaining, repairing a lot of electrical equipment, but particularly important with these 40 and 20-foot containers full of power. And it's not just a matter of wearing these suits, it's understanding the dangers and understanding why you have to wear a suit like this and how it will protect you and what the hazards are. So what are the hazards that they might encounter in this? Well, the major, other than a fire and explosion, the major hazard is arc flash. How many of you know what an arc flash is? See, raise of hands. A few know what an arc flash is. Clearly, Damien, you do. So this slide gives you an idea of the power of an arc flash. And I can tell you, if it happens, and you're a worker and it happens, you better be wearing that 40 cal suit. You better understand what the dangers are, why you're wearing it, how to wear it, and how to respond to these kinds of incidents, because they do happen, not just in energy storage, but in all kinds of high-powered electrical situations. So what are some of the components of the hazards of an arc flash? We thought over 1,600 degrees in a thermal runaway was frightening. How about 35,000 degrees at the center of the flash? 35,000 degrees Fahrenheit. I think it's extremely difficult for us even to imagine what that is. It actually melts the metal. You've got pressure waves that could drive someone through a wall, sound waves, shrapnel flying, copper that vaporizes. This is serious, serious stuff. And it's one of the reasons why it's really important that our electricians are not just trained, but they receive advanced training to protect themselves from these kinds of hazards and the people around them. And that includes not only electrical hazards, but also the chemicals and the gases that are released in these kinds of incidents. Now, I understand for some of you, you might think, well, this is really scary stuff. Maybe we shouldn't have energy storage. But I'm not here to frighten you. This is all about making sure that we do it correctly so we have the safe and effective installation and maintenance and repair of these battery storage installations. And what we should keep in mind is this is just not at some utility facility out, in a field somewhere. These energy storage devices are being installed in many types of facilities. And you see a list here: community centers, corporate headquarters, utility offices, co-ops, schools, churches are adding energy storage, in addition to utilities and industrial and military installations. So energy storage is going everywhere. So it's absolutely critical that we keep it safe. We do it right and we keep it safe. So safety is our #1 priority in the electrical contracting industry. And the key to that is, I don't know why it's doing that. The key to that is making sure that it is installed and maintained correctly. That's absolutely critical. So how do we do that? How do we make sure that these facilities are built and maintained correctly? Well, an important aspect of this, a key to it, is proper training. And we lost our slide.
We lost our monitor. Guys on the side seat.
Oh,
thank you.
Got it up here. Yeah, okay. There we go. One of the ways that we can make sure that these facilities are properly operating properly and safely is to make sure that the electricians who work on them have the training and have the knowledge and expertise to do it right and keep it safe. And that's what this training and certification program that I'm going to talk about is all about. The acronym is ESEMTAC, and as you can see, it stands for Energy Storage and Microgrid Training and Certification. And that's sort of long, so we'll just stick with ESEMTAC. What is ESEMTAC? Well, ESEMTAC is a training and certification program, just as the acronym says. It is a nonprofit organization. It is volunteer-based, and it is an industry collaborative. This is not a business that's making money training people. This is an organization that's been put together for the benefit of the energy storage industry and the protection of the people who live and use and work around energy storage. So most of the work is volunteer-based. I've been volunteering to work with this organization since 2016. It was developed initially by Penn State University and a group of stakeholders from the electrical contracting industry. It was financed by a grant from the National Science Foundation and contributions from the industry as well. And the training is based on national electrical industry standards. You see here things like the National Electrical Code, which are absolutely critical. It's a critical part of the way the electrical industry works, and also other standards organizations in the United States and internationally. So all of this training is based on those kinds of codes. It's comprehensive, it's safety focused, and it is advanced training for electricians. So why do I have advanced underlined? It's because you have to be an electrician to take this course. This is not for beginners. And in the state of Hawaii, of course, you have licensing for electricians, so you have to be a licensed electrician just to take the course. And you can see from this list, I'm not going to go through all the bullet points, but you can see from this list here of topics that it's heavily focused on the safety of battery systems and microgrids, the DC power system that they use, things like that we've been talking about, arc flash and shock protection, the chemical hazards and fumes. All these kinds of things are key parts of this curriculum for the electricians. And it's not just lectures. This course usually takes 35, 40 hours, depending on the electricians who are taking it. And it includes not only lectures, but hands-on training. So they get to work with the equipment that simulates, in many cases, what they'll be doing in the field. And here's some slides here, some pictures of some of the equipment. On the electrical side, there are batteries that are used, and I don't know why it's doing that. There are batteries that are used in the labs so they understand how this is put together and how the power, it continues to increase as they put these arrays of batteries together into larger facilities. They also are working with equipment that helps them understand the chemical and gas hazards that they will run into working with energy storage. So there's hands-on as well as lectures in this training. And some people will ask me, well, and you know, I work in California, but I get the same kind of questions there. Why do we need more training and certification? Why do we need more training and certification when we already have a requirement in the state that this work be done by licensed electricians? Isn't that enough? Well, the short answer is no, it's not. And it's not because the electricians aren't extremely well trained. They have to have 10,000 hours of on-the-job electrical contracting hands-on experience to take the state exam. So they're incredibly well trained and skilled and experienced. But that doesn't mean that training and experience includes the latest technologies. Maybe they finished their apprenticeship a few years ago, maybe 5 or 10 years ago. And that has been recognized by most states in the country, including Hawaii, where there is a requirement for continuing education. And that is in sync with the National Electrical Code, which is updated every 3 years. So every 3 years, electricians here in Hawaii and many other states have to take continuing education. And I think that's the biggest reason that we understand that no, it's not just being an electrician. You need this advanced training. The state recognizes, the federal government recognizes the National Electrical Code. They all recognize you have to update. And that's one of the things that ESAMTAC does, is it updates their knowledge with the latest technology. So I guess the conclusion here for this part is that when you put all these things together, when you put effective training that's advanced and safety focused, that it will not only increase the growth of sustainable energy. It will keep people safe, and it will reduce risk and liability for everyone. Most importantly, for the people who are in and around it, but also for the financiers, the governments, the insurance companies. It makes everything better when it's safer. The last slide here is really about why we should require certification in addition to just having the training. Isn't the training enough? Why do we have to have a certification, to go along with the training? Well, there's a number of reasons. First of all, it motivates a lot of the tradespeople to do the training when they can get a certification which helps them advance their career. It's a resume builder, so it motivates them. Also, certified training can qualify for continuing education, which we just talked about. And maybe most importantly, it is the mechanism that enables public and private entities to know who has this training and who doesn't have the training, and it enables them to require it and then identify the people who have it. So that's the story. I'm going to stick to it. And the bottom line is advanced training and certification equals safety and success in sustainable energy. Thank you.
Thanks, Bernie. I have a question here. Most of the discussion has focused on lithium-ion battery chemistries. While not yet commercially available or viable, there have been many promising R&D on alternatives such as flow battery. Does this program include any considerations for them?
Absolutely. ESEMTAC is a very comprehensive training program that covers multiple chemistries. Yes, it does. Thank you.
Okay. Next question is, although I believe the concerns are a bit overblown, there are concerns about EV battery safety. Are there programs and protocols for first responders and also consumers around EV battery safety? Also, is there such a safety program for information available for home batteries?
Yeah, so first of all, there's a big difference between the batteries that are in vehicles, the transportation batteries, and batteries that are for stationary storage. What we've been talking about through this whole presentation is about stationary storage. Vehicle batteries have their own characteristics. We do have a program for the safe and effective installation of charging equipment for vehicle batteries, which I think all know about. It's called Electric Vehicle Infrastructure Training Program, or EVITP. But that's separate and different training.
Thank you. I know for a fact that, as you can see, that I'm from IBW 1186, and we work with the fire department on showing them how to handle fires in case that has PV on solar on the roof. We show them all the risk, how to turn it on, how to turn off the systems and things like that. And the same thing with the electric vehicles now is that we voluntarily bring in some of the experts from the mainland to come down and do a class for the fire department themselves. So we've been very helpful in trying to make sure everybody is educational in safety aspects of the growing use of renewables such as that. I thank you, Bernie. I thank you for the questions over here, so you can go live on the chat area and be able to put in your questions if you have anything else in there. With all of that work of this battery storage and stuff, Ryan here, Ryan, I've spoken in the past and moderated the panel and things on workforce development, but that was from the labor side. Today, if you could, speak on the contractor and developer side of workforce and workforce development, and if you could give a brief resume of what how you got to where you are and what you do.
Thanks, Damien. And I love some of those slides there because that Plus Power project Moss built.
Yeah, I was going to say that.
Good segue. So my name is Ryan Park. I lead business development for Moss and Associates, and a lot of friendly faces out here. Been in solar since 2001, which began in California, but been living here the last 12 years, and 2 young daughters here, and this is home. And it just, despite what's going on out there at federal level, this Ohana here and the commitment and what we're doing here is just why we do this, why we continue to ride this roller coaster through the up and downs. But at Moss, in my role in business development, Moss isn't just a local company here. It's headquartered in Florida, over 20 years, started in construction. So Moss has built roughly like 10, maybe 15% of the skyline of all of Miami, stadiums, ports, F1 tracks, but has been really committed to solar over the last 10 years and here locally over the last 10 years. Nationally, last year alone, Moss built over 4 gigawatts of solar, #1 EPC in all of America. And then here in Hawaii, Moss has built over 60% of the utility scale solar that's online. So we work closely with partners like AES and Clearway and Ameresco and Longroad. We build their projects. We are the workforce doing that. And actually, Moss has brought nearly 100% of all the battery storage online here on Oahu. So we're, you need to be scared of this high voltage, and you need the professional labor on that side. Moss doesn't just do solar as well. We also build affordable housing here, thousands of units. So it's not hard to be passionate about my job when helping to solve the energy crisis and the housing crisis. And we've talked on it a little bit in some of the past, some of the last presentations about agrivoltaics, and that's something where I mean that nexus of food security, energy security, and housing security is all aligned. So don't want to go too far down the path on all of that, but we'll talk a little bit on the workforce. I think what's really good here is to frame just how big of an opportunity and what we have going on here and how much of a challenge we have in front of us, just as far as the amount of skilled labor that we're going to need. So if we talk about just the next 5 years, let's start on utility scale. Of just the stage 3 projects that have been pushed out, and if we're going to get that done in the next 5 years or so, that's going to be roughly another 0.5 gigawatt of solar and roughly another 1.5 gigawatt of energy storage in the next 5 years or so. So we will almost 50% increase the amount of battery storage that's been deployed, and same on the solar. Also on the behind the meter side, not to discount that, because over 20 years of my background was on the behind the meter residential commercial. If the 50,000 systems happen, what the governor's executive order is talking about, if the average system size is 10 kilowatts a pop, that's another 0.5 gigawatt of solar. And 99% of the residential homes are getting battery storage now. So if you just have a 2-to-1 kind of ratio, if you have 500 megawatts of solar, you're going to have at least another gigawatt hour of storage on that. And that's not even talking about the 70 to 80,000 NEM systems that don't have battery storage that can be repowered, that's going to be looking to advance there. So what are we talking about here? Well, we're talking about at least another gigawatt of PV deployment in the next 5 years, maybe 7, hopefully it's less than 5, and at least another 2 to 3 gigawatt hours of storage. Now, financial metric side, working it back to first, let's start economically. If we roll out that gigawatt of PV, and you're talking, let's say $4 a watt, that's about $4 billion of economic activity that we're talking about over these coming years. That's awesome, and payroll and taxes and people spending money here. And if you talk about man hours, so simple metrics. I started to get really granular, but I'll keep it higher level. How many man hours per kilowatt installed? Simple metric there. So if you have roughly 1 gigawatt we're going to try to deploy, and your man hours per kilowatt installed is around 20, so it'll be somewhere in the range of 20 to 25. That's 20 to 25 million man hours, or woman hours, to deploy that. Now, if you look at the Gantt chart at Moss of these projects that we're getting ready, nothing's happening right now. Or probably next year. Hopefully Kuihelani 2 starts next year and we get going. But this is backloading a tremendous amount of labor requirement. So if you're looking at 20 million man hours, or woman hours, at 2,000 hours a year of working, that's 10,000 workers needed divided by the number of years. It's a lot of hours and a lot of labor, half of which needs to be highly skilled electrical work with the high voltage battery storage we're talking about on utility scale, a lot of carpenters, laborers. So yeah, we got a lot of work in front of us, which is great.
So good news is that it sounds like we are going to get a lot of work out of this. So how does, particularly Moss, I guess, who's a developer and contractor itself, but what are the challenges you have in facing to get qualified workers? And what resources does your company use to find workers?
Good question. At least on the utility scale side, we have a lot of time to plan. So that's good. But Moss is signatory, so we work closely with IBEW, with the Carpenters Union, with the Laborers Union, with the operators, and forecast to let them know that's coming. And we know that we're going to get skilled workers coming out of that already know how to perform the work safely. But safety is like massive within Moss. I mean, Moss is a family-run. It's a privately held family company, and your colleagues and your workers are truly family, and you need to have them be safe to get home to their families. So, I mean, we get them out of the various halls. When they're on these jobs, for 1-2 years. I mean, we have obviously Mossified training of how we perform work in the field and regular safety meetings and that, but we rely on the unions to get our qualified workforce.
Okay. So that's the union side and everything, but just Moss as a whole, because I'm assuming with all this work, you also need to hire some engineers and project engineers and things. So do you find it hard to keep the employees once you hire? And does Moss offer any type of incentives and things like that? I see that. I mean, even Zippy's is offering bonuses if you stay on 6 months, or another bonus if you're bringing in a friend or something like that. So
as far as retainment, Moss has like almost no turnover. It's, hey, when you got a good company and people that you treat your employees right, people stay. So we don't have an issue with retention in any way on that way. We take care of our employees. Finding good people in a lot of those roles, being supers, project managers, engineers, and actually putting a shout out here. I think our director of engineering's here, and there you are, Bryce. Yeah, we are hiring more engineering. We are looking for more engineering, good project managers, and good supers as we gear up here. Because like we're building the Hyatt in Kapolei, we're building affordable housing. I mean, we need good people. And yeah, so it's not easy is the short answer. Normally it comes through friends, family, getting involved out there, and they come forth. Do they fit the culture and what we stand for? And then they stay.
So what I heard is it's a crapshoot out there.
It's difficult.
Like anybody else.
Yeah, it's
difficult finding.
It is.
Yeah,
it is.
It's tough. So you told us about we're probably in about that 5 years, like you said, right? But with the current president that we have and the executive orders that's been piling out every day, how do you see this affecting current and future construction jobs itself?
Oh my gosh. So Moss is in line to build over 5 gigawatts this year. I mean, just think nationally right now. I mean, there's over 200 gigawatts in interconnection queues. Like it's going to happen. I mean, we have our gigawatts lined up here. That's going to happen if you just don't rock the boat. So I'm going to keep us from going too down the horror show. Obviously, if this bill passes as is, and I think everyone in this room is aware of that, maybe lost some sleep over the last couple of weeks, it would be definitely catastrophic. At least there's other markets that are going to be far more sensitive than ours, where if the FEOC, foreign entity of concern, goes in and the transferability tax credits goes into place and makes it really difficult for that, it will be a big collapse, massive. I think here that even let's talk worst case. Let's say worst case scenario, tax credits go away. Okay. Well, it wasn't a perfect pass-through that the tax credits make it 30% cheaper. I mean, there's some inefficiencies in working through that. So worst case scenario, we're talking a 30% increase of project pricing. But if that type of collapse goes down, there's going to be a fair amount of product cruising around. We might be able to get some cheaper product. I mean, you show that slide of the battery costs going down, and obviously having been in solar for 20 plus years, I was there when we were buying Mitsubishi panels at $350 a watt a pop, and then we got down to those 20, 30 cents, now back up. And it's really frustrating for someone that, care so much about this, to know that we can deploy these batteries for much less cost, and yet we're paying exorbitant tariffs on that is silly to me, when we can get the low-cost commodity input, if you will, and the real value is in the finished product, and it's doing the work. So hopefully some sanity comes about that, and obviously if the tax credit goes away, we'll have to deal with that here, and hopefully these projects don't get too far delayed. I mean, it would be a challenge, put it that way. But I think everybody that sits here knows that, hey, with currently 70% of our energy still oil-based, we're very fortunate that oil prices are so low right now. We've been very lucky that it's come down so much since 2021. But my goodness, things can turn in a hurry if oil prices ran up, and it's the correlation to our energy cost adjustment factor and rates would be no bueno. So we need to stay the course regardless of tax credits or not, because it's still going to make sense in the long run for the islands.
Yeah, the objective is basically to give someone a career and hopefully steady work throughout his career, right? His or her career. And that I foresee as a challenge, moving forward. I know we are busy, but we want to make sure that we can sustain that as well too, right? Going down the road.
I mean, just because we build out, let's say these next 5 years we go through stage 3, we haven't even talked about the IGP, right? And then the panel just before this talking about the high voltage chargers for the EV side and the fleet electrification possibility and rolling out, resilient microgrids and cold storage and being able to power food trucks and high speed charging is really exciting. I mean, there's a tremendous amount of work that needs to be done. And so the message to the youth, as they think about it, I mean, the hours of training that goes into be a full electrician is a ton. So, I mean, I was doing the math here, 10,000 hours, they won't even be ready, but we need apprentices. And yeah, stage 3 will be built, but there's still IGP and so much more work to do. Right, and as what Shili Kamara said yesterday, I mean, as we electrify more and more vehicles, that's now more load. So you can say, well, shoot, we're nearly 40% RPS right now, but with double the load when we're back at 20. So I mean, there is so much work over the next 15 years plus to do, and that's not even talking about the final bit. How are we going to do the final bit? Are we going to make hydrogen cost effectively? I'm cautiously optimistic of that and the advancements in electrolyzers there. But there's a lot of work to be done. So hopefully we can send that message out and encourage more and more youth to go into the trades. We need it.
Okay, thank you. Bernie, I got a question for you. Regulatory policy is lagging behind technology. What can we do to help legislators and regulators better understand and keep pace with the changes which will impact the benefit of the industry overall, including workforce skill building opportunities?
Well, it's a good question, and I think it's a challenge in many places, whether it's local, state, or federal government. And what I think is effective is educating the legislators, is not just assuming that they know or their staff is going to figure it out, but actually going to visit the legislators and explaining to them what the challenges are, what the technologies are, and how we can improve our situation. What I found, and I'm not a lobbyist, but what I've found in terms of some of the meetings I've had with regulatory agencies and some of the members of the legislature in California is that once they understand it, they are generally going to make a good decision. But it's really all about education, getting to them and not assuming that they know it.
So you brought up about the certifications, right, for the batteries. What other states has either implemented something like that as part of just like this question is saying regarding the regulatory and legislative, whether it be a state law or things?
Yeah, well, what I can point to is what I mentioned earlier, is there was a question about electric vehicles. There's this program called the Electric Vehicle Infrastructure Training Program, which is a very similar program. It's volunteer-based, nonprofit for the industry. And that program started in 2011, so it's much more mature than ESEMTAC. ESEMTAC is a relatively newer program. But as a model, that program is required, that training is required by the federal government in the NEVI plan, the National Electric Vehicle Infrastructure Plan. It's required also by the states of California, Oregon, and the state of Washington just passed a requirement a few weeks ago. So there's a model for this. And those are clearly not the only education and training programs that are required, but that one's very similar because it has to do with electric vehicles, which has, of course, energy storage.
Right. Well, thank you for that. Another one will be, we face similar safety and staffing concerns down the road when it comes time to decommission with spent battery storage. What is the plan for responsible end-of-life management for decommissioned batteries?
Is that one for me?
Yeah.
Yeah. So it just happens that I served on an advisory board to the state of California EPA, and we spent 2 years discussing this issue. And the good news is that there are extensive solutions to recycling batteries of all kinds of chemistries. Now, lithium-ion is newer, but if you take one of the oldest chemistries in the battery world, lead acid, it will probably astound most people to know that 99% of the lead acid batteries in the United States are recycled. And that is the model that we used in the state of California to plan for the recycling of lithium-ion and other similar chemistries. The good news is that in the states that are focused on this, there are solutions. There are companies that are actually doing this work, that have a business of collecting these batteries and reducing them to something called black mass, which is the essential materials in it, and then separating the critical minerals and materials and recycling them. In fact, recycling of all types of batteries is actually part of the priority of the OEMs, the car makers. They rely on recycled materials as part of their feedstock to make new batteries.
Nice. Ryan, any last thoughts?
Yeah. I think just a couple things on the recycling. I think we will absolutely figure that out. There's value in that. I think that on the regulation side of batteries, there's no question there's danger in that. Although the improvements, some of those fires of older batteries, right, that went down. There's so much improvement that has gone to prevent thermal runaway or to prevent the fire within it. That we don't want regulations to go too far, and there is differences in battery chemistries that are safer than others, and not just view, oh, it's battery storage and treat it all the same. So that we need to be cautionary that we don't send it so far that we just needlessly increase the cost of building or make it really difficult. There's some things on the residential side and commercial that's a little concerning, where can't place batteries within 3 feet of doors and windows, even if it's outdoors. I mean, that's kind of like, what's going on? So we need to be hands-on and do it safely, but also not too much. The other thing, when you think about the batteries being toxic and whatnot, we can deal with those. We can get them off, recycle, and repower. What you can't do with frack ponds when those LLCs are closed up and they're gone is deal with those fracking ponds sitting there and all that, all that produced water that's sitting there leaching back into the water field. So, hey, a solar spill is a good day, and let's all try to keep positive, even though the federal story isn't so great. But here locally, we have an amazing group of individuals and collectively working together, and I'm just so thankful to be part of it with all of you. And we can do this. We can get to 70% in the next 7 years or under, and we can get further. So let's just keep it going.
Well, thank you to both of you. I really appreciate you being here. Audience, if you could give them a round of applause. Thank you.